Hello, if you haven't subscribed yet, please hit the subscription button below and sit tight as I walk you through processing in Python. So what is image processing? Basically, it's a technique of performing operations in images to enhance them or to extract useful information from those images. It typically involves transforming those images, analyzing an image features, like stuff that you get from there, such as maybe getting the size of the contours to determine the area of the object you see in this object or in those images, or also like extracting patterns and insight and data for further analysis within Python or any other software. And so more broadly, these are some of the places, few selected, there are image processing is applied. The first here is the medical imaging, so think of CT scans, X-ray, MRI enhancement, and the rest of them, but also in computer vision, where now computers could nearly do what our eyes are doing with the help of cameras and smart people that are programming this, right? And so you think of face recognition, object detection, these are all applications of image processing. Think also of autonomous vehicles, like the self-driving vehicles, like the cars that you see today that don't need to drive them. They use image processing to like know where the lane is, for example, where other cars are, and they try to stay away from them. But also satellite imaging, so the use of satellite to like help us understand how the earth looks like, what's happening, how's the climate changing, climate monitoring, mapping sea surface, mapping of the sea surface and land and stuff like that. But also on social media, creation of your typical pictures on your phone. You have some apps that would allow you to edit your picture, maybe crop them, add filters to your videos and also your images, but also effects and enhance, change the contrast, the brightness, the sharpness, and a bunch of other stuffs. So these are all practical applications of image processing, but today I will be restricting or will be constrained within Python. So I will be showing you how you could manipulate these images within Python. And to do this, you need some libraries, and a few of them are OpenCV, but also you could use Pillow and NumPy. NumPy it's a very great tool for manipulating n-dimensional array, but also Matplotlib, which you'll be using to easily plot and see what is in these images, but also Scikit-Image, which could at some point, if you want, use it to as alternative for OpenCV, or even use that main. To switch now to Spider to show you how this is done.
Great, thank you for joining me here. And so for those that are not yet familiar with Spider, this is how Spider looks like. It's where we'll be writing our code on this side. This is the editor, and in this lower section here we'll have the terminal, so just the normal terminal, and on this side we have variable explorers where our values that will be running here will be stored. If you want to check, for example, the values, the size, the types, the name, it's here that we could be doing all this little stuff. But also if you set your plots to be inline, you could also see them there and find and a lot of other stuff. Okay, you get to understand, and if you want to run your code, you can use this button, or if you select a bunch of few lines that you want to run, you just go with that. Okay, and so first is to import packages. So I've already introduced this in the PowerPoint that I did. And so here I'm importing the OpenCV, I'm importing the Pillow, and I'm importing NumPy, I'm importing the Matplotlib and Scikit-Image, just arrange them in the video. As I arrange them in the slides, okay? And so I will run this by just selecting and clicking on that. And that has run, and it's now in the memory. Okay, that's good news. So next is to set path to where we want to fetch our images from. Okay, so I added a comment. Notice this pound. Anytime you have a pound, it means it's a comment, so the computer wouldn't run this line. But it's just to help you understand what you're doing, or help any other person that's reading your code to understand what you're actually doing there. Okay, so here I want to set the image path. And so where are my images? If I do ls here, okay, I don't have any stuff here, but my images are in this particular path here. I need to go to this particular path to be able to fetch my images. So let me just go back to the terminal. So I have them here, so I'll go to pwd and grab this path. I have some example images here, and I'll paste it in that place. And this is a long string, but I think it should be fine if I do data. So that's my path. I'll run that. So that's where my images are. And since I have many images there, I would grab the files. So those files, I will import globe. This allows you to fetch some files from your computer, and so I'll just sort those images. I don't need to sort them, but sorting kind of like arrange those files for you. And so I'll do glob, and then I'll pass in the path where those images are. So that is the path, the image path, and I'll append the extension. All my images are GPGs, and so if I run this line of code now, this will fetch all my images and it will arrange them in alphabetical since I've done it sorted. And so if I check what is in these files, for example, if I grab the first stuff that is in that file, it will print and tell me the image. So this is the image that is as number 1 in that particular one, and it's called Love Nigeria, which is an image that says I love Nigeria. Okay, you could also just print everything by just doing a column there, and it will print all the files in image. So if I run that, then it will show me all the list of all the images there, like cocktail, like science sticker, this a logo, and a lot of stuff. Okay, so I'll comment that out now, and then next step is we want to read those images. Okay, I will start with OpenCV, which is the most classical and what many people uses, and so I'll just read it as image. So to read it, we just have to use the package, the cv2.imread, then we'll provide the image that we want to read. In this case, let's paste in that there and read the first image. And if we run this line, it will read the image. So this is the image. It has this by 3. These are the channels. This is the width and this is the height, and this is the range of the intensities going from 0 to 255. That's an unsigned integer 8. That's the type of the image, but that's the image basically. And if you want to see the numbers, basically if you just click on, I believe that this will open the table. So this is how it looks like. It has the RGB kind of a BGR kind of arrangement. We have your blues and your red, and yeah. And so let's now I've read this. It came in as a colored image. That's why you're seeing 3 channels, because it's actually a colored image. What if you don't want to read it as a colored image? Well, if you want to read it as a colored image, you could do as (1). So if I run this again, it will still be the same stuff. But what if I run the same line but as with 0, this will come as gray. And so if I run this now this way, then it will come just this way. So notice that the 3 went away. So this is like just a gray image basically. And so I'll plot both of them. So if I do image gray and just image, and if I run that, let's plot that. Let's start with plotting before I show you how to read it in other ones. So just understand one, you don't have to body yourself again. You go, let's understand any of them. And so let's move this to the top here. So I'll paste that there, and let's plot the first one, which is image. Okay, so if I just do this one, typically it's good to just do plt.figure. So let's just add so it first calls the figure and then issue at the end. Okay, so if I run this, it will plot the image. So this is how the image looks like. So it says I love Nigeria. The love is blue and we can't see it very well. So that's just it, and that's the title, which sort of given it there, and the axis we turned it off if not to showing us the pixels. And so what happens if you turn this off? If you turn that on, you see the pixel numbers and stuff. So these are the pixel numbers. This is actually the height and this is the width. And it has 3 channels. It's trying to tell us that this is the green, this is the white, and you see that, but the details are not that too great. But we could see that it's a colored image basically. That's the Zuma rock and Nigeria in the background. Okay. What if we plot the same image as a gray image? So if I do, instead of that, I do this and I do the gray image. What's the difference? You could also plot it as gray image, and that's what I'm trying to do now. Don't really need that. Okay, let's plot this here. There's something wrong. Okay, so this is not closing, and the CMAP is already gray, so I don't need to give it any CMAP. So if I run this, and if I pull up the 2, it plotted a single channel, a single color. That's weird. I plotted the gray. Okay, yeah, it's the color map that's giving that. So let's do CMAP is equal to gray, and if I run this again now, then we could see this is the gray image. So it's just black and white. Whereas and this one was just for color, and this white, this one is color. So you see the blue, you see the white, you see the green, you see the sky, you see the gravels, and you see the grass and stuff like that. And why this one is just purely black and white. And so that's the difference. So this one has 4 channels. It's the same way, and you could even see it if you do this on top of it, you will see the intensities. So it's just a combination of those 3 channels, where here you have just a single channel. Okay, so that's how to plot. You just need to call the figure and do PLT, which is a Matplotlib by plot, and then do an image show, and then you provide the image, and then you could provide a bunch of other stuff like such as Vmax, Vmin, and stuff like that. So if you want to do that, I could do it, for example, Vmin, which is just the lower value of intensity, and you could do your Vmax to be say 255, which is the max, and you could do a lot of other stuff there, but I think for now that's fine. And the title is just basically what you want to give it. So this one is to call image as grayscale, and you could choose to turn off the pixel number, for example, and then you call it to show. So if you plot that again, then it tells you that. You could also change the font. It's typically good to make stuff big, so you could say font size is equal to, for example, 24, and if you run that again, this font size would increase actually, so it's now bigger. Yeah, you could also change the size of this figure if you are not comfortable with this, or what you want, if you want it to fit. You want something smaller or something typically more smaller at the far side run. So if you want to change that, you just have to use something like fixed size. Fixed size is equal to, and then you pass it as a tuple. So you could say, for example, 12 or 8, 12. So making it to be similar to that one, but scaled to be bigger. Okay, so that's that for there. You could zoom in those images. I haven't mentioned that, but I'll show you in just a minute. Another way to read this, so here I've shown you how to use OpenCV to read these images. You could also use Scikit-Image to read the image, and to read it with Scikit-Image, you just have to, from Scikit-Image, there is an IO, which is an input output, and the input output has an imread, similar to what we did just here as the imread. Matplotlib also has imread, so you could also use that too. And if you want to, let's just try reading the next file. So we did the first one there. Let's read the second or the third image here, and we're calling this one as image, and we'll check the shape of this particular image after we read it. And so if I run those few lines of code, okay, it says something's out of range, so I couldn't find those amount in my files. And so how many files do we have? If you want to know how many images we have, we just print the total number of images are, and then I will do a command to the length of my files. And if I run this line of code, it should tell me how many images I have. Okay, so I have just 3 images in that particular folder, and so I cannot index 3, that's why it's complaining. But if I do 2, it will work. Okay, so if I run this now, then it has run, and it told me the shape of that particular image, and it has again 3 channels. It has the red, blue, and the green. Yep, it has the red, blue, and the green actually, and that is the width, and that is the height. Typically that's the height, and this is the width, usually in the IJ camera format. And you could always read it as just a grayscale, for example, as we did here, but now this is read as a color image. And so we could also plot this one, so we use the same command as before. So I'll just copy that, and I'll keep that because I'll be sharing this code with you. That's why I'm just commenting rather than delete stuff. And so if I delete that and change that to image, and if I run this code, it should run. And there we go. So that's the image, and it's a logo of my future company called the Science Sticker. Please look this up on LinkedIn or on YouTube. It's be a nice company that where I'll talk about that in the future videos. But now we have the logo here. We've imported the logo and the size and stuff like that about this. Remember, you could also zoom in and stuff, so you could zoom into stuff by using all these icons at the top here. Great. So we have learned how to use both Scikit-Image and OpenCV to read these images. There are also other ways to read them. Don't want to give you too much information in this video, but you could also convert, rather than just setting the channel to be just gray or color while you're using CV to read your images. You could also do the conversion from your color image from say the arrangement to change from say RGB to BGR, but also to grayscale by using this command. Okay, So you just have to, for example, the image that we read here, that was a colored image. If we do this, then the channel arrangement of the channel will change. If we run that, it will run. And if we check what is this actually, here it will, which is this one here now. It's still 3 by 3, but the values has swapped. So the channel has basically changed from RGB, which is how on OpenCV will read as BGR, and Scikit-Image will read as RBG. So typically it's RBG that is more intuitive to people, so it's always good to like convert from this back into this by using this command. So that's just basically what we're doing here. It's not critical for you as beginners. It's people that are professionals into image processing that will have to worry with that. Okay, so that's just for the start. Just know that there's a possibility of converting from RBG to BGR, but also converting that to grayscale. Okay, that's just what I want to let you know. You could also plot with OpenCV rather than using Matplotlib. So in the example I showed you, I was using Matplotlib, the PLT, to plot. You could also use in the image show in OpenCV to plot. So if I run this code now, then it plots that image, and you could see that the graphics, this is just what I want to show you. You see that the graphics is way better. So now you have like the green, white, green, which is the Nigerian flag. I love Nigeria. Before we're seeing this as blue. Now this is the recolor, which is green, and we're seeing the Zuma rock in the background. We're seeing gravels, we see the road, and then we see the national stadium somewhere around, and a lot of street lights and the skies, and see it really cool. Okay, and to quit this, then you just have to do your spacebar, and that is this way, Sarah, to destroy the window. Okay, so that's just the difference I wanted to show you. Matplotlib will be fast, but this will give you nice graphics if you just want to do quick. If you want to do just quick inspection, you could maybe do Matplotlib. If you want making something more great, more fancy, and then you could think of using OpenCV, for example. Okay, you could also use an pillow, which is a PU, to read your images. So remember, we imported the PU as image with a capital I. We could use the pu.open and point it to our files. So in this case, let's do files, and let's select the 0, the first one. Okay, if we select the first one, then we could also plot it that way, basically. So if we run that code now, it plots it, and you can also see the graphics looks great, basically. So this is like a cocktail, and it has wine and a house, and all the colors are coming up. So scripts. So far what you've learned so far is that, okay, pillow is also good. It plots. You just have to do the particular image that you wrote.show, then it just plots. It's just 2 lines. Okay, this is really fun and nice. Okay, and if you want to operate, but the caveat with this is that this data type. So if you print these values now in here, I mean, I requested for that and they showed me the image, which is crazy. Okay, well, we'll talk about that more in future videos. But you could also convert, because this will not be a typical NumPy array. You have to like convert if you really want to operate on, do some typical analysis on the image. You have to convert it to NumPy by using NumPy array, passing that, and that will convert that into that. And now you could plot this as an array. So if you check this now, it will give you some values rather than the image. You see, okay. And you could also do some operations such as filtering the image and correcting for some maybe errors, cleaning up your image. One way is to use the filters. I think the video is getting too long, so I'll stop it here. Thanks. I'll catch you up in the next video. So I'll be showing you how to use filters the rest of the time. And so this code will be available on my GitHub, and the link will be in the description of this video below. See you in the next video. Please subscribe, hit the like, comment, so that this will reach many other people. Bye.